Algebra Word Problems number 8C, more rearranging formulas to fit our word problem. In 8B, I showed you how to rearrange the formulas. Now I'm going to show you a lot more examples, okay? So, we know for word problems that we need to turn unknown amounts into variables or use formulas. We also know that when we write the expression or equation, we could substitute numbers into the formula. See? So, I want you to remember that he's a coefficient, this orange 3, because he's got this variable next to him. And as long as that variable, or any variable, x, y, z, n, p, q, r, as long as there's a variable tagging along with him, he's a coefficient. The minute the variable leaves, he's a standalone number. And he's not a coefficient anymore, okay? Formulas show how one quantity depends on one or more other quantities. For the area of a rectangle, it's A equals LW, the length times the width. And as the length and width changes, the area changes. Okay? We can rearrange the variables in this formula to suit our needs. They can be evaluated if we know all the values except one quantity. We just substitute the known amounts and solve by isolating the variable. We write the unknown value to the left of the equal sign, on this side of the equal sign, and we write the algebraic expression that equals the unknown value on the right of the equal sign, on this side of the equal sign. Like up here, if we knew the length and width, that's on the right side, and we're solving for A, the area. That's on the left, okay? Choosing the correct formula for the word problem is as important as solving it correctly. We've got to isolate the variable to one side, okay? So let's take a look at all of these formulas. Look at this. We've got perimeter and area for rectangle, triangle, square. We've got the circumference and area of a circle. We've got the perimeter and area of a parallelogram, a trapezoid, and a regular n-gon. That means, when it says n-gon, that means it doesn't matter what number you put here, it is that polygon, okay? So it could be 12 or 29, however many sides it has. So they put an n just to stand for the number. Look at, these are 3D figures. They're solid, rectangular solid, and a cylinder. So they have 3 dimensions, length, width, and height, see? Look at this, we have the volume and the surface area of a cube and a right prism, or of a right rectangular pyramid, or of a right circular cone, or of a sphere. We have Celsius to Fahrenheit and Fahrenheit to Celsius. We have simple interest, and we have the distance, rate, and time formula. A lot of formulas. These are formulas that you're going to come across in middle school and high school, okay? The most typical ones. So when we rearrange a formula, we solve for different variables. In the volume of a cylinder, it's V equals pi r squared h. That means the volume is equal to pi 3.14 times the radius times the height. And that means that we're trying to figure out what the V is, the volume is. It means that we know what these are. We know pi is 3.14. We have the measurement for the radius and we have the measurement for the height. And then we try to find out what the V is. But what if we know what the volume is and we need to find the height? So here's what we do. We say, okay, what is in the way of the h being by itself on one side of the equal sign like that V is? Well, this pi r squared is in the way, isn't it? If this pi r squared wasn't there, the h could be next to an equal sign. So we divide both sides of the equal sign by pi r squared. We draw a line and we put pi r squared underneath the v, because remember, a fraction is a little division problem, isn't it? And then we draw a line and put pi r squared underneath the right side. And what ends up happening is this pi r squared ends up getting discarded because we know that when a fraction's numerator and denominator are the same, they equal 1. So we can just get rid of it, throw it away. So now our formula ends up becoming volume divided by pi radius times radius equals the height. See? And now we can figure out what the height is. What about the area of a parallelogram? Well, the formula for it is that the area is equal to the base times the height. But what if we know the area and we need the height? Again, who's in the way of making this h, letting this h be next to that equal sign? B. He's in the way. We need to get rid of him. So we divide both sides of the equal sign by the b, and we have area divided by b is equal to h. And now he cancels out because his numerator and denominator are the same. He equals 1. All right? And remember, when a variable is by itself, like this h is by itself, we don't need a 1 in front of it to tell us that there's one h there, do we? We can see there's one h there. It's silly to put a 1 there, so we don't. We just let it drop off, we throw it away, and we leave it as just an h, okay? What if we need the base and we know what the area is? So here's the original formula. We know what the base is. We need to know what the base is. So we get rid of this h so that the b can be by itself next to the equal sign. See? So we divide both sides by the h to get rid of the h. So now we've got a, the area divided by the height is going to equal the base because now we got rid of that part. See? Does that make sense? See? The area divided by the height is going to give us our base. All right, what about the area of a triangle? So here's our formula. The area equals half of the base times the height. Well, what if we need the height and we know what the area is? If we need this height, we need to get this h by itself next to that equal sign. And who's in the way? The half and the b. So we divide both sides of the equal sign by the half and the b. And you know what happens? We get a 1, and we can discard this. So now our formula becomes the area divided by half of the base equals the height. See? Now we can solve for the height. How about the distance formula? Every time I see this, I think of the word dirt. Don't you? Okay, I don't know. Maybe it's just me. If we want to solve to get the time, this says distance is equal to the rate times the time. And if we need to know time, well, this r is in the way. So we divide both sides of the equal sign by the r, and we end up with the distance divided by the rate is equal to the time. And now we know that we can discard this r over r, can't we? How about we know the distance and we need the rate? Well, we divide both sides by the t. See? And then we can get rid of the t. And we can have the distance divided by the time is going to give us the rate. We are just bossing these formulas around, aren't we? How about simple interest? We did one of those a couple of videos ago. The formula for simple interest is the interest is equal to the principal times the rate times the time. What if we know the interest? We don't need to solve for it, but we need the time. Again, who's in the way of letting him be by the equal sign? This sassy p and r, we got to get rid of them. So we divide both sides of the equal sign by the p and r. We get rid of these guys because the numerator and denominator is the same. It just equals 1. And what do we get? The interest divided by the principal times the rate is going to give us the time. All right, what if we know the interest but we need the rate? Well, see what we got to do? We got to divide both sides by the p and the t. And what's going to happen? We're going to have the interest divided by the principal times the time is going to give us the rate because these guys are going to be gone, aren't they? We're going to get that r by itself. What if we know the interest and we need the principal? Same thing. We want to get this p by itself, so we need to get rid of this rt. So we divide both sides by the rt, and we have the interest divided by the rate times the time is going to give us the principal. And now these guys are gone, aren't they? See? You could do this. You can boss these formulas around. I think you're tough enough to handle it. I think after this you should be a pro on rearranging formulas. You think? I hope I helped, and I hope that you completely understand that when you get a word problem and it says it needs the height, you don't have to be worried because you can change that formula to help you find the height, can't you? Or the time, or whatever the different variable is that is not shown as it is in the formula. You can flip that formula around and make it do what you want it to do, okay? Keep up the good work, keep trying, and I'll see you next video. Bye.